The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 2, Elementary Hyperbolic Geometry. Section 35, Correspondence between a right-angled triangle and a tri-rectangular quadrilateral.
Draw B omega parallel to CA, and D omega perpendicular to BA and parallel to CA, figure 41. Then AD is equal to L, and CB omega is equal to alpha, and alpha minus mu is equal to the parallel angle of C plus L, equation 1. Similarly, beta minus lambda is equal to the parallel angle of C plus M, equation 1 prime. Draw B omega parallel to AC, and D omega perpendicular to BA and parallel to AC, figure 42. Then AD is equal to L, CB omega is equal to alpha, and alpha plus mu is equal to the parallel angle of C minus L, equation 2. Similarly, beta plus lambda is equal to the parallel angle of C minus M, equation 2 prime. Note, if L is greater than C, then pi minus the quantity alpha plus mu is equal to the parallel angle of C minus L. If L is equal to C, alpha plus mu is equal to the parallel angle of 0 equal to pi over 2, which are both contained in equation 2 if we understand that the parallel angle of minus x is equal to pi minus the parallel angle of x. Draw D omega perpendicular to CA and parallel to BA, and E omega perpendicular to BC and parallel to BA, figure 43. Then AD is equal to L, BE is equal to M, EC omega is equal to the parallel angle of M minus A, DC omega is equal to the parallel angle of L plus B, and the parallel angle of M minus A plus the parallel angle of L plus B is equal to pi over 2, equation 3. Similarly, the parallel angle of M plus A plus the parallel angle of L minus B is equal to pi over 2, equation 3 prime. In the tri-rectangular quadrilateral with angle theta and sides in order T, U, V, W, draw E omega parallel to DC and perpendicular to AB, figure 44. Then BE is equal to U prime, for the parallel angle of U plus the parallel angle of U prime is equal to pi over 2. D plus omega is equal to the parallel angle of W. BA omega is equal to the parallel angle of T plus U prime, and the parallel angle of W plus the parallel angle of T plus U prime is equal to theta, equation I. Similarly, the parallel angle of T plus the parallel angle of W plus V prime is equal to theta, equation II. Draw A omega parallel to CD and E omega perpendicular to AB and parallel to CD, figure 45. Then BE is equal to U prime. DA omega is equal to the parallel angle of W. BA omega is equal to the parallel angle of T minus U prime, and the parallel angle of W plus theta is equal to the parallel angle of T minus U prime, equation I prime. Similarly, the parallel angle of T plus theta is equal to the parallel angle of W minus V prime, equation II prime. Draw E omega perpendicular to CD and parallel to BA, F omega perpendicular to DA and parallel to BA, figure 46. Then EC is equal to U prime, and if AF is equal to F, theta is equal to the parallel angle of F. And we have the parallel angle of U prime minus V plus the parallel angle of W plus F is equal to pi over 2. Equation III. Similarly, the parallel angle of V prime minus U plus the parallel angle of T plus F is equal to pi over 2. Equation III prime. Now, the quadrilateral is determined by T and U. Let T equal to C and U equal to M prime. Then the parallel angle of C plus M is equal to theta minus the parallel angle of W is equal to beta minus lambda from equation I and 1 prime. The parallel angle of C minus M is equal to theta plus the parallel angle of W equal to beta plus lambda from equation I prime and 2 prime. Therefore, theta is equal to beta, and the parallel angle of W is equal to lambda, or W is equal to L, and F is equal to B. Then, comparing equation III and 3, we have the parallel angle of M minus V is equal to pi over 2 minus the parallel angle of L plus B equal to the parallel angle of M minus A, and therefore V is equal to A. Hence, to a right-angled triangle, C A lambda B mu, there corresponds a tri-rectangular quadrilateral with angles beta and sides starting from the angle C M prime A L. By reversing the order of the sides, we get the quadrilateral beta L A M prime C, to which corresponds a triangle L M prime gamma B alpha prime, or L B alpha prime M prime gamma, figure 47. If we take A prime L C M B prime as quantities determining the parts A lambda C mu B of the triangle, then we get a triangle corresponding to the quantities B prime A prime L C M, and similarly, by cyclic permutation, we get 5 associated triangles. This forms an independent proof of the result deduced in section 31 from spherical triangles.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.